To estimate finite distributed lag models, the first thing to do is to open the data. So on top of the window, you will see this open file icon over there, top left corner. So if you click this little folder, it will open a window for you, likely to choose the data that you need to use. In this exercise, we need the OCAN. So if you can go to the folder where you store the data and choose OCAN.dta and click open, you will see, okay, over there, you may notice that we have two variables showing over there already, G and U. In the result window, it also tells me where I located my data file. And the software basically is ready for analysis. If you want to see the data, what you need to do is to click this data editor over there. You have a little icon over there, data. If you click it, it will allow you to see the data. So if I click it, and let me show you the window. So this is a new window popped up when you click that data icon. So it shows you the two variables and the number of observations. If you scroll down, in total you have 98 observations, and the value for each observations are given here. So let's go back to the software window. Once over here, you may notice that we have two variables, but they are not time series variables. We need a time. So we need to generate the indicator or time index. The command to use is generate. We generate a variable, its name is called date. And that equals to a time series data, but it's quarterly, and it starts from the second quarter of 1985. So 1985 Q2. You also need to use this plus underscore n minus 1. That basically tells us Stata that we would like the variable to be incremental. So if you press enter, you may notice that over there, top right hand side, top right corner, you have a new variable in the list. It's called a date. It has no label so far, but that's okay. And let's clear the drawing. So if we go back and if you click data, then you will see that in your window, you will notice, okay, I have a DAT date is created. So essentially that's a number indicating the number of quarters from the first quarter in 1960. So this is the way that Stata keep track of date. But we would like this column, this date column, to be more intuitive or informative. So we wanted to show both the year and the quarter of that year. So there's a way for us to change it. Now let's go back to our command window. The command that we need to use is format, then %, and TQ. That basically means we are formatting a variable. We want it to be a quarterly time series data. And we specify the variable is date. So we're formatting date and change its format to be a quarterly time series. Now, if you click data right now, what you can see is the format of date has been changed. Notice in this column, it starts from the second quarter of 1985. It goes all the way to the third quarter of 2009, which is exactly what we want to see. So we created an index, a time index, and we have a time series data now, a time series data set right now. However, that's not the end of the story. We also need to declare this date is the variable that we use as the time index. So the command is ts set. So we set time series. date is the index. So it's time series variable, it's date, and you may notice there in the result window over here, the software basically tells us, oh, I understand what you're asking. This is time series variable, it's date. It starts from the second quarter of 1985 and ends on the third quarter of 2009. The step value is 1 quarter, so it's quarterly data. Okay, so we are ready for time series analysis. The first task is to generate a time series line chart. So TS line is the command. So U, G, those are 2 variables that we would like to draw a line chart for. You can also have some specification like L pattern, that means line pattern. You have solid for the first one and dash for the second one. So we use solid line for U and dash line for G. So press enter, it will take the software a little while to generate the chart. And if you did everything correctly, you will see this chart. So that's exactly the same diagram as in my PowerPoint. Of course, the legend will be too long. We have ways of changing this. So let's go back to the command window. So when we come back over here, you may notice that over there, this variable, it has a very long legend. The second one also has a long legend. That's where it causes trouble. So you can change those label either by, so for example here, if I go down to this window, it's locked. If you click this little lock, enable editing, over there, the label can be changed. So we can change is to be percentage GDP growth. So that's much neater. You may notice that the label changes straight away. And the command is given right there. So over there in your command window, whatever you did by clicking the user menu or working in those windows will be translated into Stata command lines. And you can actually copy and paste them and use them in future. So similarly, if you copy and paste this and paste in this window, now you change U to be percentage of unemployed. Just press enter, keep your eye on the variables list. You may notice that right-hand side over there, the legend of the variables are changed. So this is how to change. You can either change it by using command lines or by going to this region, enable editing by clicking this little lock and just change the value here, whatever that suits you. So let's clear those notation and come back. Now, if we resubmit this command line, click enter. Now, if you did everything correctly, you may notice that you have exactly the same chart, except that the legend over here at the bottom is much easier to read. So this is the benefit of changing those legend. Okay, so let's go back to our command window. Now we are ready to do the next analysis, that is to display the observations that I shown on my slides. So you can have a feel about the effect of lagging variable. So this is an opportunity to introduce some operators to obtain lagged variable and differenced variable in Stata. So those are 2 operators. One is L dot, another one is D dot. So L dot is the lagged operator and D dot is the difference operator. The way to use it is list. So this is the command to show observations. So which variable would you like to show? Let's show date. So that's the date. Next variable is U. We also want to see lagged U. So U lagged by 1 term, one quarter, and difference U to DU. Stata is case sensitive, so you really have to use uppercase L and uppercase D. If the variable name is in lowercase, you have to use lowercase. For example, here, if I use uppercase U, the software will not work. So that's the difference, which means UT minus 1. I also would like to show the value of G, that's GDP growth rate. And I want to see the lag 1, so lag by 1 G, lag 2 G, and the lag 3 G in 1/5. That means I only want to see the first 5 observations. Don't give me the full data set, which is going to take up a lot of space in the result window because I have 98 observations in total. So let's just have a look at the first 5 observations, the first 5 row. That should give us enough information about the effect of a lagging variable. So the table here in this window, the result window, that's the result of this command line here, this table. And those numbers are the same as the ones in my PowerPoint slide, and shows you the effect of a lagging variable and taking a difference. When you take difference, inevitably you will lose variables as well because you need to use one lagged variable to take the difference. And the longer the lags, the more variables that you're going to miss. So you can see the effect of lagging. Okay, so this is the way to display and to check your data. And you do have the opportunity to, and the flexibility of listing or showing data selectively. So if I copy and paste this command line, the highlight one, paste it here, and I will say, okay, I still want to see the same observations, but the last 3, so that should be 96/98. That means from the 96th observation to the 98th observation. If you press enter, that will give you the last 3 observations in this data set. So you can choose to see to view those data selectively, depending on which part you want to check. So the command lines is given there. So I will leave it to you to explore. So the next task is to estimate regression models with those lag terms. Okay, so the command line is regress. Not surprisingly, that means, okay, I'm estimating a regression model. The first variable will be the dependent variable. So that's du, is difference u. And starting from the second variable, those are your independent variables. Okay, so we would like to use the lagged of the lagged variable of g, and that's lag from 0 to 3, so the current value, and L2, L1, L3. Instead of spelling them out, Stata actually allow you to use this more efficient way to include 4 terms of G. So L0 basically means there's no lag. L1 is a lagged 1, L2 is a lagged 2. So this is the regression model with the difference of U as the dependent variable, and the current value of G, and the 3 lagged variables of G as the independent variable. So this is a regression model like this. So we have 3 lag terms, or is a distributed lag model with 3 lags. And that's the regression output on my PowerPoint slide. And you may notice that the last term is not significant. So what we can do is to change the lag to be 2 instead of 3. So we remove L3, and the p-value over here. So in the first regression, we include lag 3. So G lagged by 3 period. And you may notice that the p-value is not significant, which means we shouldn't include it. But after removing it, you may notice that, okay, all the variables are significant at 5% level, which is good. And the adjusted R-square over there actually is higher. So this one is 0.64, and the previous one is 0.63 something, which means after removing an insignificant variable, actually the performance of the model is improved. So that's a good sign.